Dear student, this is one of the familiar example. A limit in terms of summation or sometime limit can be converted into integral also. Limit of sum, so integral can be used to evaluate. So in this question, summation r equal to 1 to n r by r power 4 plus r square plus 1. Actually, and we have to make this particular question as a telescopic series. Telescopic series. Actually, what is the telescopic series? And nth term of the given series can be written as a difference of and two terms. So every term of the series can be written as a difference of two terms. So that kind of series is known as a telescopic series. Telescopic series. Now what to do? Let us take r divided by r power 4 plus r square plus 1 with the factor form. What is the factor form of r power 4 plus r square plus 1? So this is like x square and plus x and plus 1. X square plus x plus 1 also can be factorized. Then r power 4 plus r square plus r. What are the two factors? R minus r square minus r plus 1 into r square plus r plus 1. We can factorize, just multiply and check it. R power 4 and r square, r plus r cube minus r cube cancel. Then r square left, then 1 into 1. So r square minus r plus 1 into r square plus r plus 1 is nothing but r power 4 plus r square plus 1. Then how to factorize mean r power 4 plus 1 separate plus r square. So make it no two group. Remember student, a square plus b square equal to a plus b the whole square minus 2ab. Applying this is r square plus 1 the whole square minus 2r square, already plus r square, correct? Then r square plus 1 the whole square minus 2r square plus r square minus r square. Now we can factorize a square minus b square form. R square plus 1 minus r1 factor, r square plus 1 plus r1 factor. This is the method of and factorizing r power 4 plus r square plus 1. This following the same way, we can try to factorize x square plus x plus 1 also. And one more thing, what is the difference of the denominator? R square cancel and plus 1 cancel. The difference equal to 2r. So we can adjust 1 by 2, 2r by r square minus r plus 1, r square plus r plus 1. Okay. The 2r, the difference of the two factor. The 2r will be written difference of two factor r square plus r plus 1 minus r square minus r plus 1. The denominator r square minus r plus 1 into r square plus r plus 1. Okay. We continue. Then 1 by 2. This is a technique of partial fraction. 1 by r square minus r plus 1 minus 1 by r square plus r plus 1. And this is general term r by r power 4 plus r square plus 1. Now if we take a summation r equal to 1 to n r over r power 4 plus r square plus 1 will be equal to 1 by 2 summation r equal to 1 to n 1 by r square minus r plus 1 minus 1 by r square plus r plus 1. Okay, dear student, and if you take r equal to 1 to n, there will be n terms. Out of cancellation, only two terms alone left, the highest term and the least term. In the expansion, the highest term, I'll put r equal to 1 in the first part. In the first one, if you take r equal to 1, this is the highest term. 1 by r equal to 1 means 1 by 1, 1. 1 is the largest term. 1 is the largest term. Okay. The maximum value 1. The maximum value 1. Then the least term, put r equal to n in the second part. 1 by n square plus n plus 1. The highest term, this is the least term. From the general term, very important, from the general term difference of two terms mean, from the help of the general term, we can find the largest term and the least term. How to get largest term? In the first part, put r equal to 1 to get the largest term. To get the least term, put r equal to n in the second part of the partial fraction. There are two fraction and separating the general term. In the general term, in the first one, put r equal to 1 to get the largest term, and put r equal to n in the second term to get the least term. Okay, this is shortcut. I'll explain what is the reason behind this. So this is the whole thing. Now we can take limit. We take limit. What's the limit? N approaches infinity. Summation r equal to 1 to n or divided by r power 4 plus r square plus 1. So limit n approaches infinity 1 by 2 1 minus 1 by n square plus n plus 1. Taking limit, the second term 1 by infinity 0. So 1 by 2 minus 1 over infinity. Final answer 1 by 2. What's the limit of summation r equal to 1 to n or divided by r power 4 plus r square plus 1 is nothing but 1 by 2. So dear student, this question also is similar to the previous one. So the telescopic series will come. The nth term of the series should be written as a difference of two terms. This is a telescopic series. At the same time, we should apply Properties of inverse trigonometry function. Cot inverse of r square plus 3 by 4 given. So applying properties of inverse trigonometry function and telescopic series techniques, this can be evaluated. As a first step, you should remember the property cot inverse of x is tan inverse of 1 by x. Very important property of inverse trigonometric function. Cot inverse of x is equal to tan inverse of 1 by x. Applying this, cot inverse of r square plus 3 by 4 in term of tan inverse 1 divided by r square plus 3 by 4. Then tan inverse of 1 by, from 3 by 4 we can separate 1 plus 1 by 3. 1 plus 1 by 4, that is r square plus 1 by 4. R square plus 1 by 4, and now we can't because 3 by 4 is less than 1. Some adjustment required. How to adjust? 3 by 4 in term of 1, 1 minus 1 by 4, correct? 1 minus 1 by 4. So 1 plus r square minus 1 by 4, correct? Then tan inverse of 1 by 1 plus r square minus 1 by 4 after factorization, r plus 1 by 4, 1 by 2, r minus 1 by 2. The difference of these two factors, r plus 1 by 2 and r minus 1 by 2, the difference is nothing but 1. Remember, here 1 is nothing but r plus 1 by 2 minus of r minus 1 by 2. So this 1 can be replaced by tan inverse of r plus 1 by 2 and r minus 1 by 2. The denominator 1 plus r plus 1 by 2, r minus 1 by 2. Remember student, this is of the form tan inverse x, your middle minus, and minus tan inverse of y is nothing but tan inverse of x minus y by 1 plus xy. So this is of the form. Using this formula or this identity, so the term can be separated further. Tan inverse of r plus 1 by 2 minus tan inverse of r minus 1 by 2. So this is nothing but and cot inverse of r square plus 3 by 4. Okay. When you take a summation of cot inverse of r square plus 3 by 4 r equal to 1 to n. The other side also summation r equal to 1 to n and tan inverse of r plus 1 by 2 minus tan inverse of r minus 1 by 2. So that's why uh, the nth term of the series is written difference of two terms. So this also considered telescopic series. This also considered a telescopic series. Once the summation introduced means this is nothing but SN, sum of n term. How to get sum of n term? And in the two term, put n equal to r equal to 1. Which of the term will be largest one? That term should be retained. R equal to 1 means tan inverse of 1 plus 1 by 2. Here tan inverse of 1 minus 1 by 2. So tan inverse of 1 minus 1 by 2, pi by 4. Pi by 4, or we can, and so now all these steps. R equal to 1. R equal to 1, tan inverse of 1 plus 1 by 2, 3 by 2, minus tan inverse of 1 minus 1 by 2, 1 by 2. Tan inverse of 1 by 2. This is first term. Second term, take r equal to 2. Tan inverse of r equal to 2 means, and 2 into 2, 4, 4 plus 1, 5 by 2. Minus tan inverse of, and 2 into 2, 4, 4 minus 1, 3 by 2. So this pattern continue. Nth term, tan inverse of n plus 1 by 2 minus tan inverse of n minus 1 by 2. Okay. After cancellation, if you look at the cancellation, and first term cancel, tan inverse of 3 by 2 positive, tan inverse of minus 3 by 2 negative. This and this cancel. Similarly, this and this cancel. Okay, these two are left. Then what are the remaining terms? Tan inverse of n plus 1 by 2 minus tan inverse of 1 by 2. So this is sum to n terms. Summation r equal to 1 to n cot inverse of r square plus 3 by 4. Correct? For the actual question, we should take limit. Limit n approaches infinity. When approaches infinity, cot inverse of r square plus 3 by 4. Taking limit, first term tan inverse of infinity minus tan inverse of 1 by 2. Tan inverse of 1 by 2. The tan inverse of 1 by 2 is nothing but 5 by 2. 5 by 2 minus tan inverse of 1 by 2. Using properties of inverse trigonometry function, 5 by 2 minus tan inverse of 1 by 2 and cot inverse of 1 by 2 or tan inverse of 2. Cot inverse of 1 by 2 equal to tan inverse of 2. Dear student, the tan inverse of 2 is the final answer. Tan inverse of 2 is the final answer.